Madam, you can start, madam.
Thank you. Thank you. I welcome you all. I am Dr. Sunita. I am a faculty at IIT Palakkad, and I'm also the Joint Secretary of ICI Kochi. Uh, in the name of the whole ICI Kochi team, led by Dr. Anil Joseph, I welcome you all to this webinar, which is very special for us, especially due to the speaker. ICI Kochi's mandate of promoting quality and innovation in concrete construction has always been in the forefront in the state. And based on this, the team has been working very hard to bring to its audience the who is who in concrete construction, both in the country as well as across the globe. QCrete webinars that we are fortunate to have QCrete to partner with are one of the most prominent regular events of ICI Kochi. I would first thank you, Crete, for being associated with ICI Kochi for these events and bringing to us, facilitating, bringing the best speakers in this event. Today we have Dr. N. Subramaniam. I don't even have to introduce him to you, but there will be a formal introduction. Thank you, sir, for agreeing in
Sure.
spite of all the time and space distance between us. You have kindly agreed to deliver this very contemporary topic of pervious concrete to this audience. Let me not take more time. Once again, I welcome you all and I thank you, Crete, Dr. Kaushika, Dr. Shelley, for their support in this event. I hand over the mic to Kaushika, sir.
Thank you, madam. On behalf of QCrete India Private Limited, I consider we are honored to present Dr. N. Subramaniam, and I can say a man of such knowledge and such experience, so humble, it cannot be captured in the words. And I'm very happy that he has agreed to come and present on our platform today. And it is really a great occasion for us to hear from him. And I'll just introduce to him about him to the audience. Dr. N. Subramaniam. He was born in Tamil Nadu and had his schooling in Ramakrishna Mission Boys High School, Chennai. He had his civil engineering degree from Tyagaraja College of Engineering, Madurai, 1972, and structural engineering degree from College of Engineering, Guindy, 1974. Mr. Subramaniam earned his PhD from IIT Madras in 1978. Under an international process, he was selected by the prestigious Alexander von Humboldt Foundation, Germany, to do postdoctoral research in Technical University Berlin during 1982 and later at TH Bundeswehr Munich during 1984 after returning from Germany. After returning from Germany, he successfully ran his own consulting, computer design consultants and teaching institution, computer technological institute for about 25 years. Has designed over 600 projects in RC and steel structures and trained several students, many of whom are now working in US. They did pioneering work in computer-aided design in 1980s and developed special purpose computer programs to run on PCs. His books are very famous, and more than many of his works, the books are very, very popular. Building Materials Testing and Sustainability, he has written. Design of Steel Structures, Limit State Method, he is very famous. Design of Reinforced Concrete Structures, Oxford University Press, he is very famous. Space Structures, Principles and Practice, he is known to many of the structural engineers. And as I said, his books are very, very popularly known, not only in India, in many parts of the world. In addition, he has contributed more than 300 papers published in international Indian journals and conferences. And he has authored a series of articles and gems of structural engineering in the Journal of ISSC. His contributions have resulted in many recognitions. As I said, the time is limited and we cannot capture his contributions in 5 minutes or 10 minutes. He has been awarded Fellow of Indian National Academy of Engineering, Life Fellow of ASCE, Honorary Fellow of AAE, Best Book Award from ACCE in 2000, 2011, 2013, ACCE Gaurav Award 2021, ICI L&T Lifetime Achievement Award 2013, Distinguished Alumnus Award CEG Gundi 2015, Tamil Nadu Scientist Award 2001, etc. to name a few. Dr. Subramaniam took active part in several professional associations, ACE, ACI, ICI, ACCE, etc. And he has been publishing in many magazines, and he has been more than anything else has been guide to many of the students. Still now he is working with many of the structural engineers, civil engineers, and his students across the globe, giving them consultation in many platforms, as well as in verbally training them continuously. And as I said, it is difficult to capture his achievements in 5 minutes. We once again thank Dr. Subramaniam for accepting our invitation and coming and giving lecture on our platform. Thanks a lot. Thank you very much, sir.
Thank you.
Yeah.
Dr. Sunita Nair, Engineer Kaushika, and all those who are attending the webinar. Good evening to you. I first of all thank Mr. Engineer Kaushika for inviting me to give this topic, and also was consistently telling that I should give timing. Of course, I don't usually accept because of the time difference, but I think this time suits you well. All of you can agree with me that the temperature is increasing globally, and not only temperature, the climatic change. Due to this, we have high temperatures everywhere. Of course, many of you might have experienced high temperatures in India, and but also we have heavy rains due to cloud bursting. That is 1 month rain in one day, and also water scarcity and forest fires. You might have read in newspapers that a lot of forest fires are happening not only in the USA, Canada, and also in Greece. So all these things are happening due to global warming or climatic change. Actually, I want to use the word climate change instead of global warming, because we also have a lot of rain, and also in some places it is very cold, etc. And can we mitigate some of these effects? It is not known, but I am going to talk about a product, Pervious concrete, which if properly executed, will mitigate some of the effects of climate change. Let us see how it can be done. So as I have already told, global warming is a long-term heating of Earth's climate system observed since the pre-industrial period, that is between 1850 and 1900, due to human activities, primarily due to fossil fuel burning, which increases heat trapping greenhouse gas levels in the Earth's atmosphere. Actually, this term is frequently used interchangeably with the term climate change, though the latter refers to both human and naturally produced warming and the effects it has on our planet. It is most commonly measured as the average increase in Earth's global surface temperature. Actually, of course, as I told you, all of you might have experienced this global warming. as of July 18, 2023, Phoenix, USA reached 118 degree Fahrenheit, breaking a record of 150 Fahrenheit set in 1989. Also, as of July 24, 2023, for continuously 24 days, the temperature was above 110 degrees Fahrenheit, breaking the record of 18 days set in 1974. In addition, the heat index in the Middle East reached 152 degrees Fahrenheit. This is the upper limit of human tolerance. Actually, it is 95 to 105 degree Fahrenheit in humid areas. In addition,
Sir,
the sea surface temperature. Yes.
slides are not moving. I think you are moving slides, sir.
Yeah.
Slide is in the first slide only. Can you?
Oh, I am seeing the third slide.
Okay, it is not. It is in the first slide. Can you just?
So I don't know how to do that.
How can we? You must know. Okay. We'll try
Shall I
to.
close my view?
Yeah.
Sir, can you accept that mouse control?
Yeah.
Sir, once close the PPT and reopen it. Can you please?
I am talking from evidence of global warming. That slide.
Sir, can you close the PPT and reopen it, sir?
So should I close my view?
Yes, sir. Yes, sir. You close it.
How to do that? End show?
No, sir. No, sir. Only close the PPT.
Only close the?
PPT, sir. PPT.
Yeah, that I have closed.
Okay. It is. ಇದೆ ಸರ್ ಅದು ಓಪನ್ ಆಗಲ್ಲ ಅವ್ರದೇ ಓಪನ್ ಆಗಲ್ಲ Sir, can you close that window and reopen it, sir? That PPT.
What should I do? So, repeat again.
PPT, sir. Hello.
Yes.
Sir, close the PPT and reopen it, sir.
Reopen. Okay. Yeah.
But it's not working, sir. Sir,
1 minute.
ನಮ್ದು ಸ್ಕ್ರೀನ್ ಶೇರ್ ತಗೊಂತಿಲ್ಲ ಸರ್
Stop sharing.
yes ma'am stop it. Once again start sharing now.
Okay.
Kindly change. Yes, ma'am. Yes, ma'am. Kindly change the slides, ma'am.
Okay. So which screen you want to go?
Good.
Next slide, ma'am. Yes, ma'am. Now it is changing. Thank you.
So is it moving now?
Yes, sir. Yes, sir.
Okay, okay. Actually, sea surface temperature is also increasing. Recently, in South Florida, the sea temperature record was as high as 101.1 Fahrenheit, which will affect coral bleaching, sea level rise, and also change in the ocean currents. And recently, I have also read that pumping of 2,150 gigatons of groundwater has led to a change in the Earth's eastward tilt to about 80 centimeters. These impacts are already felt around the world, and it is going to be more severe in the future. The effects may be rising sea levels, which are inundating coastal areas and displacing millions of people, more extreme weather events such as heat waves, droughts, floods, and wildfires. And it also will affect the agricultural yield, which could lead to food shortages. The spread of diseases as insects and other pests move into new areas. Actually, you might have read, I think 1 or 2 years ago, locust swarms threatened food supply in 23 countries, including India. The loss of biodiversity as plants and animals are unable to adapt to the changing climate. Population growth coupled with urbanization result in significant impacts on the environment. It also, of course, as I told you, ambient temperature increases and it decreases air quality, and water runoff is increased. Quality of runoff water is decreased. The weather patterns are altered, and reduction in farmlands and subsequent food shortage and deforestation occurring at a rapid rate, with 0.8 hectares of rainforest disappearing every second. And due to all this, we have water scarcity all over the world. At least 2/3 of the global population, over 4 billion people, live with severe water scarcity for at least 1 month every year. Nearly half of these people live in India and China. You see the dark red color is severe. And as I told you earlier, there are cloud bursts instead of rain, which results in extreme amount of precipitation in a short period of time. That is 50 to 100 millimeter per hour. In India, it occurs when clouds move from Bay of Bengal or from Arabian Sea towards Himalayas, bringing 75 mm of rain per hour. On October 20, 2021, it occurred in a small town of Salem district, Tamil Nadu, resulting in 213 mm rain in a single day. Several such incidents have occurred all over India and resulted in flooding of cities. You might have seen in newspapers photos of all cars and even houses in the water. This shows one of the occurrences. Route 202 in Yorktown, New York was flooded on July 10, 2023 after torrential storms. In 2022, Governor of New York earmarked $1.1 billion for restoration and flood risk protection. In this scenario, it may be interesting to note that the percentage area occupied by roads and pavements varies depending upon the city or country. In USA, the average is 18% of the total land area. In some cities like Los Angeles, it can be as high as 30%, which is very considerable. And where this is in this scenario, our pervious concrete will be of great help. Actually, we have concrete or asphalt pavements, and even sidewalks are also covered with concrete, unlike rural roads where it's mud road. In urban roads, which are paved with concrete or asphalt roads. The latest trend is to cover most of the areas around dwellings with concrete interlocking blocks, since they may add visual appeal to a building. So I am showing one interlocking block in New York. You see the vast area which is covered. Of course, there are small gap between the blocks, the rainwater will not go through it if there is a heavy rainfall. So another example from Chennai, concrete interlocking blocks, and these openings also may be covered with the dirt, so it will not allow rainwater to percolate. When runoff on roads, it can pick up soil contaminants. That is the additional problem. Petroleum, pesticides, and fertilizers, which may be dissolved or suspended in the runoff. So these pollutants can reach streams, rivers, lakes, oceans, polluting these water systems and their related ecosystems. 35% of groundwater wells in agricultural southwestern Ontario, Canada, was tested positive for pesticides. This is an example. This can happen anywhere in the world. Similar observations in USA and other countries have also been found. The problem with fertilizers in water bodies is they allow algal blooms and excessive plant growth. It leads to lack of oxygen, and also pesticides and herbicides are harmful to human and aquatic life. As I told you, in New York, they have allocated $1.1 billion for mitigating these effects. This is due to the cooperation between Copenhagen and New York. The solutions they have suggested are deploying flood net sensors to get more data of where the rain is happening, where there is water clogging, etc. And designing gutters, underground storage tanks. That is also a good area. A lot of underground storage tanks are being built in USA to capture this excess water, and diverting water to the harbor through large pipes. That has been done in Copenhagen. And then permanent stormwater detention ponds. I don't know whether such ponds are there in India, but I have seen several such ponds in USA. And then slope protection or grass strips, temporary sediment traps, silt fences, and diversion trenches. And they are also planning to build sunken play areas or parks, which converts as water basin during a storm, and curbside rain gardens. Lately, a different approach is getting attention. That is, don't let the water run off through pervious or porous pavement. So that is the topic of our talk. So before that, I want to talk about one more conventional rainwater harvesting system. Of course, in many cities, they have done it. Here, the water is collected from building terrace or pavement and then channeled into an underground storage tank or a soak pit that is connected to a well, thus recharging groundwater. In Tamil Nadu, late former Chief Minister Jayalalitha made it compulsory for all houses, but this project will not be successful if it is not properly maintained. If the first downpour is heavy, water collected in soak pit will overflow as percolation not considered. A system to eliminate the pollutants during first flush of rain should also be provided. Contents of soak pit, as I told you, should be replaced periodically for effective filtration mechanism. Otherwise, the water will have contaminants. So the pervious concrete is not a very new idea. The earliest application is reported to be in 1852, but it was not adopted vigorously. So this shows the photograph of a pervious concrete from National Ready Mixed Concrete Association. You see that water being poured is percolated immediately through the concrete. It has 15 to 25%. It can have 15 to 20% void structure, and it allows 120 to 320 liters per minute to pass through each meter square with a typical flow rate of 3.4 millimeter per second. That is equivalent to 200 liters per meter square per minute. Actually, this shows the normal stormwater collection and stormwater collection through pervious pavement. In the normal thing, when there is a rain, there is a traditional pavement, concrete or asphalt, and then the water is collected through the drains, and what happens is the contaminants which are on the pavement, petrol, etc., they are being washed through the stormwater drain, and only in the what is that where it is collected, it is being treated. But in the pervious pavement, when there is rain, the contaminants are filtered here itself, and only the water percolates through that, and due to the base, the stormwater is collected in the subbase. So the advantages of using pervious concrete are, first I will read about the environmental benefits. It reduces stormwater runoff and recharges water tables and aquifers, helps to mitigate flooding and improves tree growth, allows air to infiltrate the soil because of the openings, making it practical to pave under the drip line of trees without suffocating the trees. And it, as I shown in the previous slide, it allows the natural treatment of polluted water by soil filtration, result in cooler stormwater runoff, which benefits streams and lakes. And also, concrete can be made from locally extracted and processed materials. Hence, it is considered as green, and unlike asphalt, produces no toxic runoff. The aesthetic appeal of this pervious concrete may also be enhanced by including colors in the concrete, which we will see in the next slides. And the safety benefits are, it minimizes flash flooding and standing water, and skidding is lowered because it is of the rough surface. It slides colored surface both reduces heat island effects and lowers lighting costs due to its more light reflectance than asphalt. The color can be chosen to improve reflectivity even further. Light color also earns lead points, which we will see later. Glare from wet pavement is virtually eliminated, and it also reduces tire noise. Researchers at MIT found that cool pavements which reflect solar radiation and emit less heat lowers air temperature in Boston up to 1.7 degrees centigrade, and in Phoenix 2.1 degrees centigrade. Such pavements also reduce greenhouse gas emissions in Boston up to 3% and in Phoenix 6%. You see that this is called this heat island effect. That is, in rural areas, the temperature, if it is 85, in the midtown or in the center of the city, it can reach up to 92 degrees. And they also found that cool pavements can offset total greenhouse gas emissions of Boston up to 1 to 3%, and in Phoenix 0.7 to 6% for a 50-year analysis period. The worldwide range of savings can be as large as 5 to 44.7 gigatons of CO2 equivalent. Of course, I have given in some of these slides some references, so you can go through them for more details about what I am discussing. And because of this, of course, in pervious concrete, it is important to have a subbase like this. And part of water absorbed by soil under pervious concrete will change to water vapor. During this change, energy in the form of heat is absorbed, causing a natural cooling effect. So that's what I told, that the cooling water only will be sent to the streams. And economics, that is savings and other benefits, reduces or eliminates the need for storm sewers or retention ponds, increases facilities for parking by reducing water retention areas, increases permissible area, and may qualify for permeable area credit in LEED, and it is also recognized by LEED, requires less costly repairs than blacktop, longer service life and lower life cycle cost than asphalt. Of course, there are some disadvantages of any product. Here, the runoff from adjacent areas into pervious concrete needs to be prevented. Usually, reinforcement is not provided, but if it is provided, epoxy coated bar should be used. It has got variable permeability. That is, permeability may not be same throughout the area. Over vibration may significantly reduce the permeability, may have higher maintenance requirement than regular concrete pavements, less effective at suppressing weed growth, and the gravel between the joints should be prone to being washed away. So you usually provide a curb. These are the applications of pervious concrete: residential roads, streets, and driveways. Of course, in streets, if you are doing, it should not be for heavy loaded vehicles. Low volume pavements, that is, sideways and avenues, parking areas, tennis courts, subways for traditional concrete pavements, in well linings, swimming pool decks. These are the applications. Of course, when you are using pervious concrete, for it to function properly, it should be used on flat, low-grade areas. Compared with conventional pavements, it requires stricter measures while preparing subbase to achieve the required permeability. Mechanical properties prohibit the use of it in high-speed roads or roads exposed to heavy load traffic, which I already told you. Maintenance such as vacuuming or sweeping may be required in certain areas to preserve the pervious properties. So I am showing one or two examples of the pervious concrete pavements. This is a large concrete parking lot in USA. So another two examples. This is at the Olympic venues in and around Beijing in 2008 Olympic. And as I told you, you can use different colors. Here it shows a red colored pavement, and here different colors have been used. So in an earlier slide, I told you that we can have LEED credits. Of course, many of you may be knowing that LEED is the Leadership in Energy and Environmental Design. Of course, similar things are available in India also. So these are the credits which are available for limiting stormwater runoff, for filtering total suspended solids, for shading or materials reflecting incident sunlight, for reducing landscaping water usage by storing and using stormwater, for using materials with recycled content, and for using materials sourced within less than 805 kilometer radius. Of course, greater than 10% for 1 point, greater than 20% for 2 points. Of course, let us see what is pervious concrete. Actually, it is a concrete with no sand, creating a substantial void content. Actually, not using sand also is advantageous in India because in many areas, sand is in short supply. As with any concrete, proper mix design has to be done so that we have enough void ratio. And using sufficient paste to coat and bind the aggregate is required, which results in highly permeable interconnected voids that drain quickly. A low water cement ratio of about 0.3 is often employed. Of course, the pervious pavement may be of all asphalt or concrete, but what I am discussing is only about pervious concrete. They both contain openings in their surface and throughout their depth, allowing water passage. Some insulation may have larger aggregate borders, framed with pavements to handle heavy rainfalls that I already told you. There are several names for this. It also is referred as porous concrete. I don't think that is the correct terminology. Permeable concrete, no fines concrete, gap graded concrete, and enhanced porosity concrete. These are the different names by which it is called. So I told you that porous pavements are slightly different. These are concrete grid pavers. As opening, you see there are openings in the grids where most water passes through, or permeable interlocking concrete pavers. The joints here, we have already seen some of the slides. Here the joints permit some water flow, and then plastic reinforcing grids. Here it is shown here. They are 90% open. The plastic grid provides strength, and the infill allows water passage. And there can also be natural rock paver with the gaps in between the rocks, and through it concrete the water can flow. As I told you, typical void ratio is 15 to 25% in hardened concrete with NM aggregates, which can increase to 30 to 40% void content with 12 mm aggregates. There is a ACI code, ACI 52210 restricts the maximum size of aggregate to 1/3 of the specified pavement thickness. So that is the restriction given in the ACI code. As I told, the mixed proportion is very important for any concrete. So these are some of the mixed proportions which I have collected from different publications. The cementitious materials can be from 270 to 415 kg per meter cube. So what I mean by cementitious material is the cement may be replaced by 10 to 30% of fly ash, 20 to 50% of blast GGBS, and 5% of silica fume. Of course, chemical mixes are also used, so the dosages are recommended by the manufacturer. And narrowly graded aggregates are used. That is the 1180 to 1480 kg per meter cube. Water cement ratio is 0.25 to 0.34 with chemical admixtures, and 0.34 to 0.4 without chemical admixtures. As I told you, 0.3 is the normal thing adopted. Cementitious materials versus aggregate ratio is 1:0.21 to 0.25. Fine aggregates are normally not used, and in some places they have also used polypropylene fibers, and fibers may be 13 to 19 mm or 50 mm long. Of course, as I told you, the addition of fine aggregate will decrease the porosity, and hence it is not used, but in some places it can increase strength. And coarse aggregate size, as I told you, 10 to 20, but normally adopted is 10 to 12 mm. So this is a cross section of the pervious concrete insulation. This porous concrete layer may be 125 to 250 mm thick, and then you have the subbase, which is very important, where the water is collected. It can be greater than 230 mm. Then there is a filter fabric and geotextile which can be used. It is optional. It can be used. And as I told you, this gap graded gravel or crushed rock, less than actually 25 mm size, acts like a reservoir to hold water. And in some places, we can also have drain pipes to convey larger volumes of stormwater runoff to catchment areas for potential reuse. It is only an optional. And it is very important that we should not over compact the subgrade soil because of the percolation requirements. So these are the key points for the success of any pervious concrete pavement. Subgrade preparation, it should be uniform and properly compacted. The concrete should have correct amount of water for mixing. The concrete should be compacted and finished without excessive effort, as I told you. Sufficient curing should be performed. in a timely manner and for a sufficient duration. This shows the casting of pervious concrete. I will skip this. The compaction is immediately after initial strike of concrete, rolling with in two perpendicular directions with a light roller, and it's very important that vibrators should not be used. And this shows the curing of pervious concrete pavement. To prevent moisture loss, it is critical to place a protective plastic sheet immediately after the concrete is compacted, and it is also recommended to slightly mist the concrete surface before applying the protective plastic sheet. Of course, these are the some do's and don'ts. I have already discussed all these things. And regarding the compressive and flexural strength of pervious concrete, which is not very important, only if, when you have when you are applying it in a big road, it is required, or heavy loads. Typical compressive strengths are between 13.5 to 20 MPa. Flexural strengths are critical for the quality and ranges between 1 to 3.8 MPa. This shows a hydraulic design of pervious concrete. It has 15% effective porosity. Then every 25 millimeter depth can hold 3.8 mm of rain. Thus, 100 mm thick pavement with 15% effective porosity can hold up to 15 millimeter of rain. Hence, a 10 millimeter thick pavement with 15% porosity is placed over 150 mm thick sub base of 25 mm gravel with 40% void, can absorb and hold 75 millimeter of rain. The calculation is shown here. The subgrade absorption rate of 12 mm water per hour is considered a minimum. Of course, this structural design, we can follow the standard pavement procedure, which are provided in different codes. There are also some software programs available for the structural design. I have given only two. Street pave developed by the PCA. NRMCA also, they have a concrete pavement analyst program. So in summary, pervious concrete pavements can store large quantities of rainwater and allow it to percolate into the underlying soils. They reduce the entrance of pollutants in stormwater systems. It has no fines concrete in the mix. They have several advantages. They can be used to harness precious rainwater, not only for irrigation, but also to recharge groundwater, which is not happening in many places in India. They can mitigate flooding due to cloud bursts. They can reduce heat island effects in cities, and even greenhouse gas emissions as revealed by the study conducted at the MIT. Thank you very much.
Thanks. It is an extraordinary presentation, Dr. N. Subramanian sir.
Thank you.
Now from Latashri, from QCrete, Latashri will ask questions on behalf of the audience. If any questions are there, Madam Latashri, can you check?
Hey, good evening, everyone. Now we will move on to the question and answer session. So first question is pervious concrete is used in construction of building?
No. It is, of course, some buildings, I think in some papers I have read that in Germany they have been used, but not because it allows water to percolate. I don't think that it is advisable to use it in the in regular buildings or where corrosion is concerned.
Okay, thank you, sir. Next question. Which type of cement is suitable for the pervious concrete?
I think any type of cement. because in the concrete mix design slide, I have told that we can use cement with fly ash and GGBS also.
Okay, thank you, sir. Next question. What about leachate? It was asked by Bhargav.
Sorry, repeat.
What about leachate?
I'm not able to get.
What about leachate? Leachate, sir. Wastewater.
Reinforced concrete.
What about leachate? It will pervious or not? Like that they were asked 90.
Can I see the question?
So I'll ask next question, sir. Which type of fibers will be suitable for impervious pavement?
Fibers.
That's huge.
Actually, fibers are normally not used. Polypropylene fibers are better because of the porous nature of the porous concrete. Otherwise, the water percolating will corrode the steel fibers.
Okay, thank you, sir. Next question. As the walls are present in the concrete, we cannot attain the characteristic strength. Will it be okay to users, sir? It was asked by Sudeep Pujar.
Actually, as I told, we should not use it for normal roads, which carry a truck load and heavy vehicle loads. Which is normally it is recommended for smaller roads where the traffic is less, and also for pavements and other places. Nowadays, around the house, we have a lot of area which is covered by concrete or interlocking blocks. So there, if you use pervious concrete, it will recharge the groundwater, and due to that, the water level in grounds also will increase. Actually, I can. There is no example of pervious concrete in India which I know. But when our former Chief Minister Jayalalitha implemented the groundwater recharge through percolation pits, the next year they found that the water levels were higher. So if the percolation pits themselves are able to increase the water level, definitely the use of pervious concrete will increase the water table to a higher extent, and also flooding will be reduced.
Okay, thank you, sir. Next question. Is it possible to achieve M30 grade pervious concrete so that we can use it in heavy traffic areas like highways? It was asked by Abu Bakar Khan.
Use of highways?
It is possible to achieve M30 grade pervious concrete so that we can use it in heavy traffic areas like highway.
I don't know, but it has not been used in big highways. But of course, there are some recommendations in which they are allowing to use that is steel reinforcement also. But I am not sure of any application that has been done in USA or in other places.
Okay, thank you, sir. Next question. If we wish to enhance compressive strength, what are the ways? It was asked by Dada Patil.
Okay, I just indicated that if you use a slight amount of fines, it can increase the strength, and also the fibers definitely will increase the strength. But strength is not the main criteria here. It is the percolation is the main criteria because our aim is to reduce the water runoff and also to have water stored in the subbase below so that it can percolate slowly into the ground so that the groundwater is enhanced. Hello.
Hello.
Yes.
Next question. As Pervious concrete is sold as a value-added solutions product, it is expensive and not preferred usually. How to overcome this? It was asked by Janavi Oza.
Regarding the cost,
Yeah, Pervious concrete is sold as a value-added solutions product. It is expensive and not preferred usually.
no. It is done actually. Since sand is not used, it is not. It will not be very expensive.
Okay. Thank you, sir. Next question. Why it is not so important for flexural and tensile strength? It was asked by Nitish S.
Because the main purpose of using pervious concrete is to have pervious surface, so that the water can go down, and also it is used mainly in small streets, pavements, and then where small cars and other things go. The strength is not very much required.
Okay. Thank you, sir. Next question. What is the durability of pervious concrete and conventional concrete? Asked by Jagadishwaran.
I don't know about it, but I have near my house they have installed various concrete for the past 5 years in the library. I find it still good without any blemish. So unless long-term research is done, we cannot say about it. But I don't think that it will be a problem.
Okay. Thank you, sir. Next question. Do you want to suggest this type of concrete for all the park areas in India? Asked by Prabhakaran.
All the
All the park areas in India.
yeah, you can use anywhere in the world, and they have been used in many countries. As I told you, in my area itself, it has been used in the car parking area of the library. It's a vast area.
Okay, thank you, sir. Next question. What is the slump range for pouring pervious concrete? Asked by Abu Bakar.
Slump is not like normal concrete only.
Okay. Thank you, sir. Next question. What is the mix ratio of pervious concrete? Asked by Ramesh Kumar.
I showed it in a slide already.
Okay, thank you, sir. Next.
Actually, no sand is used. Otherwise, it is exactly like normal concrete. Now,
Okay.
no sand is used, and also 10 mm to 12 mm aggregates are used. So that, and you should not vibrate it or roll it with heavy rollers, because our aim is to have porosity.
Okay, thank you, sir. Next question. What is the maximum size of aggregate we can use for pervious concrete? Asked by Rishant.
Yeah, as I told you, 10 to 12 mm, but in some cases 20 up to 20 mm have been used.
Okay, thank you. Can we do the self compaction? Asked by Rampant.
I don't think self compaction is recommended, because self compaction concrete will produce a dense concrete, isn't it? So dense concrete will not allow any water to percolate. So self compacting concrete should not be used.
Okay, thank you, sir. Next question. What about drainage issues in soils with high clay content? Asked by Jalli Sai Vamshi.
Actually, we are using it for drainage only. Of course, that also I have pointed out, in some areas, it may be required to blow the dust away from the surface of the pervious concrete so that its void ratio is maintained.
Okay, thank you, sir. Next question. Is pervious concrete is pumpable? Asked by Enosh Gadam.
Sorry, pervious concrete is permeable?
Pervious concrete is pumpable.
Pumpable? Oh, I think it is pumpable. But
Okay.
I don't know, but because mostly it is coming in a truck and they are, of course, pumping is not required because it is laid on the road only, mainly. So pumping to great heights is not required, isn't it?
Okay, thank you. Thank you, sir. Last question. Is this used for seismic proof structure? Asked by Balaji.
Seismic structure?
Seismic proof structure.
It's a pavement. So I don't know, during earthquake, even properly laid concrete pavements are breaking. So it will definitely break.
Okay, thank you, sir. Lots of questions are there. So the questions will be sent to through mail for you, and you can answer it through mail, sir. Thank you so much.
Thank
Now
you.
I'll hand this session to Dr. Sunita Nair for vote of thanks.
Thank you, madam. First of all, thank you, Dr. Subramaniam, for that enlightening talk. Am I audible? Sorry.
Yeah, you're welcome.
Yeah, thank you. On, as I said, it's a very contemporary material, the need of the hour. And thank you also for giving the brief discussion on the problems that are being faced due to the overuse of resources in concrete construction. Thank you, sir, for your valuable time and sharing your experience and expertise in this area. On behalf of ICI Kochi, I thank QCrete once again for having conducted this webinar. And on behalf of ICI Kochi, I also thank the entire participant group who has joined today, and Madam for handling the question answer session and also very nicely handling the question answer session. Thank you very much. I hope that in the next upcoming webinars also we have this kind of participation, because it is the response from the participant which actually gives us all energy to go forward and organize more events of this kind. Thank you very much. Thank you, sir. Thank you, Kaushika sir, and the whole team of QCrete.
Thank you all.
Thanks a lot, Dr. M. Subramaniam, and then
You're
Dr.
welcome.
Sunita. And again, I say in this evening, for all the audience who have come and having patiently here.
Okay, so shall we sign off, sir?
Thanks a lot. Thanks a lot once again.
Okay.
Thank you, sir. Yeah.
Okay.
Thank you.